Uh, the topic is DynamoDB. So this is just quick summary of the research paper DynamoDB. So DynamoDB is a NoSQL cloud database. So the problem it is trying to solve is consistency at scale. So we are trying to achieve consistency at scale using DynamoDB. It was developed by AWS team of Amazon. It was built by them, and the research paper that we are reading is also developed by them. With DynamoDB, we are trying to achieve reliability, scalability, and consistency. So, for scalability, so Amazon system. So Amazons have various system. So the Amazon systems makes trillions of API calls to DynamoDB. So like 89.2 million requests per second they have mentioned. So this much of API calls are made to DynamoDB. So this is a huge amount of requests per second. So this much of request, and we have to process the request in single digit millisecond. So this performance we should have. So we are not talking only about volume, it's about speed and consistency also. Although the volume is huge, but we are not only concerned about volume, we are also concerned about speed. The speed should be good, it should be single digit millisecond performance, and the consistency should also be good. How it came? So Amazon was facing a challenge. Amazon needed highly scalable key value store. So for things like shopping carts and all, they wanted highly scalable key value store. So earlier back in the days, they were using traditional relationship based database for all the use cases. So there are different type of use cases like payment, like shopping carts, like I can keep on stating. So for all of them they were using traditional relational database. So for pretty much everything they were using this. So the problems for using relational database in every kind of scenario is scaling becomes a bottleneck. DB could not keep up with the increasing user load. So this is the problem. So for example, a same relational database I'm using for a shopping cart as well as payment system, so scaling becomes a bottleneck. So after that, they come up with the solution of service oriented architecture where each service have their own database, each application has its own database. So they had Dynamo earlier. So Dynamo is different, DynamoDB is different. So DynamoDB is evolved version of Dynamo. So they had Dynamo. So as the name suggests, it's dynamo, coming from dynamic. We'll come to know why it's dynamic. So dynamo. So the its initial answer of Amazon to scaling challenges. So as we have already seen, they were facing scaling bottlenecks by using traditional relationship traditional relational database for pretty much everything. So they were facing scaling bottlenecks. So this was their initial answer to scaling challenges. So the Dynamo was also not perfect. So it has a single tenant system. So that means each team in Amazon has to manage its own Dynamo installations. So that means each team has to be expert in DB, and it was a hurdle for major adoption. So this single tenant system becomes a hurdle for major adoption because each team in Amazon has to manage their own Dynamo infrastructure, Dynamo installation. So that means each team has to be expert in DB. So indirectly it becomes a hurdle for major adoption. At the same time, Amazon have other databases also, like S3 database and simple database. So these databases were popular. Why? Because as the name suggests, it's a simple DB. So it was fully managed, no SQL, elastic database. That was the pros of this database. And the cons is request throughput was less in case of simple DB. In DynamoDB, this was the pro. So limits on storage capacity. So a database have like 10 GB of data per table, so this is the limit on storage capacity. And similarly, S3 have uh, pros and cons. Pro is easy to manage, and cons is scalability and consistency. So devs don't want daily burden of managing infrastructure. So even with this cons, scalability and consistency issue, uh, they went with this because it was easy to manage. It was popular because it was fully managed, no SQL and elastic. Even the performance is bad, but still because of age, devs do not want daily burden of managing infrastructure. So these two are popular. So but Amazon wanted such database which is easy to manage, like S3 and simple DB, but also have scalability, consistency and high throughput, like DynamoDB, like Dynamo. So they combined Dynamo and these two. So Amazon wanted highly performant DB like Dynamo and ease of use DB like simple DB. So they wanted to combine these two superpowers into a one. So Dynamo DB is the solution which is having best of both world. So from Dynamo it is having scalability, solution, consistency, availability, high throughput. These all solutions Dynamo, this DynamoDB got from Dynamo, and SimpleDB gives the feature like ease of using. So in 2012 they introduced DynamoDB, which has both best of both world. It is highly performant and easy to use. Now, how is data organized and managed at fundamental level? So in DynamoDB, how is data organized at very fundamental level? This is the very important question. So in DynamoDB we have table. So table is collection of items. So just like in SQL, we also have table, and the table is collection of columns. The row of columns of, we have columns, right? Here instead of columns we have items, and table in DynamoDB is collection of items. So each item has set of attributes. So each items have each row have multiple columns. Similarly, each items have many attributes. This item uniquely identified by primary key. So this, like we have a row, in row we have a primary key which is used to identify the entire row, and similarly this item is uniquely identified by primary key. Now primary key we define while creating the topic. So we tell table. So while we are creating the table, we tell this is the item, and in item this is the primary key. So this primary key will help to uniquely identify this item. Now this can be simple part. So this primary key can be simple partition key or composite partition key. So simple partition key is like simple key, and the composite partition key is part composite key is partition key plus sort key. So this partition key determines whether the item will be stored physically. So this is used to determine where the item will be used to store physically. So in the disk where it will be used to store, this is used for that. And we have a sort key. In composite key we can have some partition key, same partition key, but some different sort keys to make them unique. So key should be unique. So we can have same partition key among multiple items, but sort key should be unique, so that item will have a unique primary key which is made from composite key. so that we can uniquely identify each item. Now query the data in more complex way. Let's say we don't want to query only based on the primary key, we want to do in more complex ways, so beyond the query. So let's say so we have secondary index. So secondary index lets you query data using other than primary key, fields other than primary key. So the answer is secondary index. So it lets you query data using other than primary key. So DynamoDB interactions. So how we will interact with the DynamoDB? So it happens through API. DynamoDB provides us API to interact with the database. So we have operations like put item. So item is like a row, put item means like adding a item in a database, update item means updating it, delete means deleting, get item is getting the database, getting the particular item based on primary key from the database. So this supports ACID. ACID is basically atomicity, consistency, isolation and durability. So this is a popular, so ACID is popular USP of SQL database. So here also in DynamoDB you are getting ACID, even if it is no SQL, still you are getting ACID. This is a very nice thing. So atomicity means either full or none. For example, there is a transaction which have multiple steps. Let's say there are 10 steps, 5 steps got executed successfully, on the 6th step it failed. So everything that was executed will be rolled back. So either the whole transaction will be succeeded or it will be failed. So it is atomicity, atomic level. So each transaction is like an atom, either it will succeed, that means whole code will be executed, or it will fail, even if some of the thing passes but it is not completed fully. So the system will roll back, and yeah, so that is atomicity. Consistency, multiple replicas we'll have. So this is, let's say, the leader replica. For this leader replica we'll have multiple copy replicas. So consistency means, so these all replicas should be in sync, so it is highly consistent. Isolation, this durability means it is getting saved in the DB. So scalability is DynamoDB's expertise. So scalability is its USP. How DynamoDB achieves scalability and availability, we should see. So DynamoDB automatically divides each table into multiple partitions. Let's say we have an employee table. So let's say this is employee table. So automatically DynamoDB divide into multiple partition. Let's say partition of employee 1, partition in employee 2, like this it will divide into multiple partitions. Now each partition whole chunk of table data. So this was a table, this was heading data. So first partition will have some chunk of data, second partition will have second chunk of data. Likewise each partition will have some chunk of data. Partitions are self-controlled storage unit. They store the chunk of data, and their process unit, they process the data. So process the data means if you want to add something in DB, if you want to get something from the DB. So the partitions are self-contained, they are able to do it, they are able to store in a storage unit, they are able to process. Break down table into smaller and more manageable pieces. Basically we have a table, that table is a huge table. So now DynamoDB, what it do is it breaks down the big table into smaller manageable pieces, and that piece is called partition. So this is how Dynamo achieves scalability. How? Because has multiple so each partitions has multiple replicas. So since it is having multiple replicas, it is highly available. Why? So each replicas will be in different zones, will be kept in different zones. So it provides high availability, reliability, because each replicas will be having multiple replicas. Durability, how replica stays in sync. So how replicas stay on sync and how they decide who is in charge. So each replica group uses algorithm. So that algorithm is named multi-peg sorts. It is a consensus algorithm. Any replica can start election. Any replica can start election. So only once leader is elected, it starts in charge, it stays in charge. So any replica can start election. So once a leader is elected, it stays in charge. So only leader can write and strongly, so the right operation is only done in leader. So it is strong, and we have, if we have to do strongly consistently read request, then also leader is the go-to person, because leader has the most recent data. So any replica can handle eventual consistent reads. So if we are okay with some in sync in the data, but we want faster, so then we can read from any of the replicas, any of the in sync replicas. But if we want strongly consistent read request, so in that case we have to go to leader. So leader is responsible for writing operation, and it is responsible for strongly consistent read request. So there are some cool optimizations that the team has done, that is log replicas. So bringing up faster. So what happens is, only have the most recent log entries, not entire history of data. So its job is fast recovery of if storage replica fails. Now talking about DynamoDB, the star of this both world. So it is built using microservice architecture. So there are multiple microservices that are involved that work together. So first microservice is metadata microservice. It stores information about tables, index, replication. And then we have request routing service that is responsible for authentication, authorization, redirection of each request to the right server. So we'll have multiple servers. So the redirection, authentication of request, authorization, all will be done by request routing service. Similarly, metadata microservice is responsible to store info about tables, index, and application. And we have auto admin microservice, which is called central nervous system of DynamoDB. It is the most important part of DynamoDB because it handles admin tasks like creating table and responsible for health of all the servers. Individual partition orchestrates all the behind the scene operation, does health checks, replace unhealthy replicas, kicks off recovering process. How they managed. Okay, so we have one more microservice, storage service. So it manages customer data. So storage service is responsible for managing customer data. Now how they manage capacity at beginning plus challenges. So now the problem is capacity management. So how they manage capacity at the beginning. So and what were the challenges for that. So at earlier they used to manage like this: customer, that means whoever is using the DB, had to specifically provision how much read and write capacity. So the role of capacity management is given to customer. They have to read and they have to specifically provision read and write capacity they need for their tables. So we have tables, so we need to mention read and write capacity. So it was measured in read capacity unit and write capacity unit, that we call as RCU and WCU. So now because it is tied to individual partitions of unit, so there was issues. Capacity partition is linked together. So although as the load increases, the partition will split automatically. But since there is a high linkage, high coupling between capacity and partition, there were some issues. So the two of the most important issues was hot partition issue and throughput dilution issue. In hot partition issue, like when application access certain items way more frequently than others. Let's say there is a feature in app that is very widely used. So that feature is, let's say, fetching up some particular thing. So at that time, throughput was fixed at the partition level, gets overloaded, reject request even if capacity for the whole table seemed enough. Capacity for whole table is enough, but then this split to multiple partition. Relax, but this is hot partition, this is overloaded. So this is the bottleneck here, this is not good. And second is throughput dilution. When partition split, so we have a table and it splits into multiple partitions. So when we have multiple partitions, and even the partition, if it grew huge, it splits into multiple partitions. So when partition splits, its capacity divides into new partitions. So let's say this partition is having 10 GB of capacity. Now it's split it into two partitions. Each partition will have 5 GB of capacity. So lower efficient throughput per partition. So per partition throughput gets decreased because the capacity get decreased. So can request so this can cause request rejection. User feels like service is down, so this is not good again. Even though you thought you have provisioned enough capacity, still the way it is distributed can still become bottleneck of your performance. So there is a workaround that people used to do, that was over provision. What was so for double safety, we just over provision so that our application will not fail. But so it was just like a buying a giant truck when you all need is a sedan. So in that there were improvements. First is bursting and second is adaptive capacity, and these were the basic improvements. There are more improvements. So introduction to have more flexible and provision model. So let's say first is bursting. So bursting, so it only worked for short spikes. Let's say there are short spikes on certain features. So this bursting feature, this bursting techniques that they used only works for short spikes. Allows partition to temporarily exceeds its capacity. So partition have some capacity. Let's say this partition have 5 GB capacity. So bursting techniques allows partition to temporarily exceeds its capacity. Let's say total table capacity was 100 GB. So this table was divided into multiple partitions. This partition's capacity was 5 GB, but like other partitions are relaxed. This is the hot partition, so it is up to the mark. But still this bursting allows this partition to use extra capacity from the table. So allows partition to temporarily exceeds its capacity by using any spare capacity at partition level. So at partition level, if there is any spare capacity, so it will allow the partition to use it. So if there is a sudden spike in traffic, this will absorb it. This bursting technique will absorb it. So but the issue was it only worked for short spikes. So if you have to work for short spikes, the bursting is the solution. Now the second thing is adaptive capacity, but it still reacts to throttling. So in adaptive capacity, we become proactive. Moderate the capacity uses, automatically boost the throughput of partitions. So there is busy partitions. So we will figure out what are the busy partitions, and we will automatically increase the capacity. So these are partition, let's say, and there was table. This table was divided into multiple partitions. This table was having 100 GB of capacity. So this was having, let's say, 25 GB. This was having 25 GB. This was having 25 GB, and this is a busy partitions. Now the provisioning, this will automatically increase the provisioning of this to, let's say, 50 GB, because this is a high reacting to traffic pattern and adjust accordingly. Basically, traffic pattern we will react to and we will adjust accordingly. But this was also it still react to throttling. So in case of throttling, it was still an issue. So after that, there was global admission control, GAC, game changer. So moved from partition level to centralized system. So it uses token bucket mechanism to track total capacity consumption of a table. So each router in the system have its own token buckets, periodically checks GAC service to refill it. When request comes into, router tries to use token from the bucket, GAC have global view of token uses, gives token back based on table's provision capacity. Each partition burst always as long as the table capacity is not exceeded. When they How they prevent individual server to get overwhelmed. Now we were talking about partitions, now we will talk about at server level. So they prevent individual server to get overwhelmed by balancing consumed capacity across the whole system. Usually different sets of hardwares are used with different capabilities, so to handle uneven load. So there are uneven loads. To handle that, they constantly monitor replica in each server. So they have servers, so these servers, they constantly so let's see, there's a partition and there are 5 replicas. These 5 replicas are in 5 servers. So in each of the servers, they constantly monitors the replica. So any replica throughput gets too high, it flags. Let's say this is the replica, this replica's throughput is getting high, so it flags it for migration for less busy server. So we have to offload the work, like load balancer for partition. So we have auto admin service figures out where to move partition, maybe to different availability zone. So it is a serious it is working as a serious orchestrator. Splitting for consumption, this is a very powerful technique. It is a technique to handle situation where a lot of traffic is going to small subset of items within a partition. So there was table, this table was divided, so there was table, so this table was divided into partitions, and these partitions had items, these partitions have items. So let's say all the request is going to this and this partitions, so small subsets of partitions. So a lot of traffic is going to small subset of items within a partition. If a partition's throughput goes over limit, if a partition's throughput goes over limit, system will split it into 2 new partitions. If there is throughput is increased, it will split it into 2 new partition. So it does it strategically, it does not do it blindly. Still not a silver bullet for every scenario, so that's why DynamoDB is smart enough to detect when not to split and when to split. So DynamoDB can split, does not split blindly, it's split strategically. On demand provisioning model. So in DynamoDB we have on demand provisioning model. You don't have to worry about capacity planning. DynamoDB scales automatically, constant monitor traffic, and can instantly handle. It keeps adding capacity as traffic increases. So as the traffic increases, it keeps adding the capacity, like a database that grows with you no matter how much your load increases. So DynamoDB is a database that keeps growing with you no matter how much load increases. As load is increasing, it is growing with you, it is increasing the capacity. Relief for devs, as you know, DB can handle whatever you will throw at it. So data durability plus correctness. So there are multiple level of data protection. The most important is write ahead logs, so written into replica, backed up in S3. Even if server crashes, we can still recover data from those logs. Silent errors, so how we will handle silent error, that we do using checksum at every stage, and there is a technique called scrubbing that we will use. Now how Amazon handles or how DynamoDB handles availability. So distributing data across multiple availability zones. So power outage test it do. So write need healthy leader replica. So if you want to do write operation, then we need a healthy leader replica, because the write operation is only performed at the leader replica. But let's say if there is no leader replica, then there will be, let's say leader fails, so there will be an election, and in election leader is elected, a new leader out of all the replicas will a new leader will be chosen, and that leader will perform the write operation. Also 2 out of 3 replicas should acknowledge write. Not only the write operation will happen at the leader, but that 2 out of 3 replica should acknowledge the write. Read consistent, a strong consistent read if you want, then also leader is needed. DynamoDB, I was trying to go through the research paper of DynamoDB, and this video is just for myself so that I can go through the video and understand what I have read, because otherwise it's very easy to forget whatever is read.